What is this? It's going to be 2x plus This
288.
is 288. Very good. That's the relative atomic mass of that substance, the relative molecular mass of that substance. Since you don't know x, when you get x, you'll be in position to get the relative atomic mass of that substance. So percentage composition is going to be 28%. Relative atomic mass is going to be 2x out of 2x plus 288 times 100%. That is first of all that. So if you want to remove this, we divide this by 100, divide by 100. So this one divided by 100 is going to be 2.28. The percentage goes, which is going to be 2x into 2x plus 288. If you solve this equation mathematically, if you solve the equation mathematically, what is the value of x? This one is going to be, you cross multiply. This is 1, cross multiply. This is 2 times 0.28. You get what? You get 0.56 x plus 0.28 times 288. You get 80.64, which is equal to 2x. Bring the x's together. Since this one is more than this, so we take this one the other side. That means we are going to subtract 2 minus 0.56, where we get 1.44x is equal to 80.64. Divide by 1.44. Divide by 1.44. We get 80.64 divided by the answer. Therefore, x is 50. X is 56. Is it the x that was given?
Yes.
Now, where people would say the number was hard? So, if you have x, what is the relative molecular mass of that substance? Just compute and put it here. 2x plus 288. 2x plus 288. You have x. What is the relative molecular mass? We don't have calculators here.
100.
It is 400. 400. So, Melissa, was that number hard? Was the number hard?
No.
I've told you, people did not try. They just left the number like that.
But Chame tried.
Lynette, did you try? Ready?
I did, but I will.
You can imagine what Lynette is saying now at this time. Bright. Bright?
Yes.
Did you do? Okay. We shall see that later. Okay. So if that is the way of getting that element or relative atomic mass or any percentage of anything, we have the topic, we looked at the topic of empirical formula. We say this is the simplest formula which expresses the ratio in which different atoms are present in a molecule. So the steps are: write down the symbols of the elements, their percent composition, find the number of moles by dividing the percentage by relative atomic mass, and then find the mole ratios, and then write down the empirical formula. If the mole ratio is in fractions, then round off your nearest number if it is very close to the whole number. If it is less or not close to the whole number, you get a number that if you multiply by it, it gives you the answer. So that is, let's look at the examples here people fail to do. They say they did not submit. That is a lame reason. The reason is people did not try. They were very busy enjoying the weekend. If you look at this, they say, I'm not going to do one. Let me start from here. From 7. The rest, people will do, all for purposes of understanding what we're saying up there. Let's go back and do at least one of these. Let me start from 3. 3 is saying calculate the empirical formula of a compound formed when 1.8 grams of carbon. We are writing, the first step is to write the symbols of the elements present. We have carbon, and forms 2.4 grams of a hydrocarbon. 2.4 grams of the hydrocarbon. That means a hydrocarbon has hydrogen and carbon only. So those are the two. So if carbon has 1.8 grams, and they say if the two react, they form a hydrocarbon with CH, and the mass of that hydrocarbon is 2.4 grams. If you have carbon as 1.8, what is the mass of hydrogen? If you have this, so for you to get this, is going to be 2.4 minus 1.8 grams. So carbon is going to be 1.8. What about hydrogen? What about hydrogen? We have people with calculators. Yes?
0.6.
0.6. Okay. Now that is, we have got the percentage composition. Now we want to get the mole ratios. Get the mole ratios by dividing this by relative atomic mass. It's going to be 1.8 divided by 12. That's for carbon. And then we have 0.6 divided by 1, which is hydrogen. So if you divide this by this 12, what do you get? Sonia, 1.8 divided by 12, what do you get? People don't have calculators. Lynette, what do you get? Yes, Letitia.
Yes, teacher.
1.8 divided by 12, what do you get?
0.15.
0.15. Then this is 0.6. Now after this, we get this is number of moles, not mole ratios. We are getting number of moles, sorry. Number of moles. And then here now we are going to get the mole ratios. Mole ratios. If you are getting mole ratios, we get the smallest between this and this. I think 0.6 is the smallest. We shall have 0.15 divided by 0.6 to 0.6 divided by 0.6. 0.6 is the smallest,
Excuse
isn't
me,
it?
teacher.
Mm.
Then the formula, see, you're writing percentage composition as 1.8. I see 1.8 is not the percentage composition.
Now they have not given us the answer in terms of percentage composition, but they have given us the answer in grams. So there is no reason of converting to percentage composition, isn't it?
Yeah, but why did you still write percentage composition? Yet you're not writing. Yet you don't have the percentage composition.
It is okay. We shall also remove. If you want us to remove this and put mass, percentage mass. Yes?
Yes.
Okay.
Yes.
Okay, let us start from there. Mass. This is the mass, 1.8. This is 0.6. Now we are going to divide this by the mole. To get the mole, the number of moles, we divide by the relative atomic mass. Carbon from the table is 12. Hydrogen is 1. So we got this and this. Now we are going to get the mole ratios by dividing this by this. We choose which one is the smallest between this and this. So the smallest is 0.6, isn't it? Melissa? Tracy? 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 I think it is.
Teacher,
Yes.
the smallest is 0.15.
In mathematics, do we read numbers like that?
0.15.
0.15. Okay, so this is 1 already. 0.6 divided by 0.15, what do you get?
4.
4. So these ones are already automatically there, so there is no need of multiplying or there is no need of rounding off. So we write C1H4 as the empirical formula of that substance. This is the empirical formula. Now, if they ask for the molecular formula, you look at what they have given you. Have they given you the molar mass? Empirical formula. It is not there, so the answer stops there. They only want the empirical formula. But now, if you look at this number, they say calculate the molar mass. Calculate the molecular formula. Now, this one, you see, if they ask for the molar mass, they have given you the molar formula. If they're asking for the molecular formula, they have given you the molecular mass. So from here, you continue from here that empirical formula times a certain number you don't know gives you the molecular mass. Now, since you have the molecular mass of this substance, which is given here, let's look at 4 to finish those problems. They say that calculate the molar mass of a hydrocarbon with the empirical formula. They have given us the empirical formula as C2, CH2, and the molar mass is 28. So here we are going to say empirical formula times a certain number we don't know will give us the molar mass of the substance. So empirical formula is CH2 times a certain number. Then we are going to get the molar mass, which is 28. So C is 12 plus hydrogen, which is 1 times 2 into brackets N is equal to 28. So this is 12 plus 2, which is 14N, is giving us 28. What is the value of N? N is 2, isn't it? So if N is 2, look for the empirical formula, the molecular formula. So empirical formula times N gives us the molecular formula. So this one, the N we have found N, they give us this molar mass so that we look for that N. That N is the one that's going to help us find the molecular formula. So if you know the empirical formula was CH2, you multiply that by 2, you'll be getting C2 H4. That is the molecular formula from the molar mass of that substance. So if you get this number, it should give you back the 28, the molar mass of that substance. So that is the answer there. So where are these people? Are they quiet, or people just turn on their phones by the one, they go and sleep? People turn on their phones, after that they go and sleep. So you shout from here, you think you are talking to people, but you are talking alone. Are people there in this group? Yes?
Yes.
Those are
Yes.
two. Those are three. So the rest have just turned on their phones and they have gone. Eh? Okay. So now, like this one, 7, they are saying find the empirical formula of the following compounds, the reaction described below. 10.8 grams of magnesium form 1.8 grams of an oxide. So you see, in the 10.800 grams of magnesium, it produced an oxide. Which oxide is that? Magnesium oxide. And then down, this oxide has both magnesium and oxygen. So now you write the elements of substances that are reacting. You have only magnesium and oxygen. So in magnesium alone is 10.8. What about oxygen? If the overall whatever is 18.00 grams, what is the mass of oxygen alone? I want answer from Ready. Ready? 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 Unmute, and give me the answer. What is the mass of oxygen? The mass of oxygen. If the mass of magnesium is 10.8 and the total mass of magnesium oxide is 18, what is the mass of oxygen alone? Yes? Somebody with a calculator, what is the answer there?
7.2.
7.2. That is good. So we are going to divide this by, to get the number of moles, we divide this by the relative atomic mass. What is the relative atomic mass of magnesium? Relative atomic mass of magnesium in the table. Yes, Lynette.
It's 24.
Very good, 24. What about oxygen?
It's 16.
16. Very good. Bright, you divide for me this and get for me the answer to 3 decimal places. 10.8 divided by 24. We are now getting, these are the number of moles. Then afterwards, you are going to get the mole ratios. 10.8 divided by 24. Granoma. I'm waiting to write. I'm waiting to write what you are saying. Please, all those numbers we are reading, 2.4, they are all here on the first page of mole concept here. They are here. You look at them and write. So the molar mass of magnesium is 24. That's why we divided by 24. The one of oxygen is 16. We got it from here. Oxygen is 16. So don't be scared of where these people getting these numbers from. They all come from there. Okay. When you divide this, what do you get?
0.45.
0.45. Then this one?
Also 0.45.
0.45. So our mole ratios are very easy to get.
0.45.
Yes, you have seen. So getting the mole ratios, we divide by the smallest. I think the smallest is the same number. So we just divide by 0.45, divide by 0.45. So the answer is 1 to 1, giving us our formula of magnesium oxide as MgO. So the rest of the numbers are there. Please make sure you do them. Just like Lynette was saying, she tried and did not get the answers. That was, I know it was just a way of hiding. That instead of telling her that I did not do the numbers, you look for ways of hiding. So all this is part of you now. Calculate empirical formula of a compound from which the following analysis results were obtained. 27 is percentage composition. This is carbon, this is oxygen, this is carbon, oxygen. All the rest are there. So these ones you can get. Now our main point of discussion today was this, but we have a minute to reconcile, ask questions about this, because after this I will not expect this kind of silence again.
Teacher,
Yes.
what of us who never attended the
Hey,
lesson?
where were you?
The monthly money was done, so I had to pay again.
Okay. But you have got something out of this discussion?
Teacher, no.
No. Okay, that's the one point taken. Any other point of concern? Rudy is quiet. I don't know what is in her mind. Tracy, Sonia,